Hello my dear students, welcome back to our channel. Today we can make a question paper discussion. Frequently asked 6-mark questions from the chapter Sequences and Series. Don't forget to subscribe to our channel. Okay, we can go to the video. Okay, first question. First part. If the sum of a certain number of terms of the AP 25, 22, 19, etc. is 116, find the last term. Question from the section Arithmetic Progression. And second part, find the sum to n terms of the series 1 into 2 into 3, 2 into 3 into 4, 3 into 4 into 5, etc. From the section Sum to n terms of special series. These two questions I have already discussed in the respective sections. Anyway, we can see. First one, here the AP is given and also sum to n terms. Sn is also given. We have to find the last term an. You can see here the AP is 25, 22, 19, etc. So we can say the first term a is equal to 25 and the common difference d is equal to 22 minus 25, that is minus 3, or 19 minus 22 minus 3. And Sn is also given. Sn is equal to given 160. We know Sn is equal to n by 2 into 2a plus n minus 1 into d. For an AP, equation for sum to n terms. And also to find last term, we have to find last term. Formula for an is equal to a plus n minus 1 into d. Here we have a and a common difference. We need n. We can get n from Sn. Here substitute for Sn. Here n by 2 into 2a plus n minus 1 into d. Instead of a, 25. That is 2 into a is 50 plus n minus 1 into d is minus 3 is equal to Sn is given 116. Take this 2 to this side. We get n into 50 minus 3n minus n minus 1 into minus 3 is minus 3n plus 3 is equal to 116 into 2, that is 232. This is, we can write minus 3n square plus 50 plus 3 is 53 plus 53n is equal to 232. Multiply both sides by minus 1. We get 3n square minus 53n is equal to minus 232. Take this minus 232 to this side. Then we get 3n square minus 53n minus 230 plus 232 is equal to 0. Here minus 232, taking to this side, we get plus 232. This is a quadratic equation with a is equal to 3, b is equal to minus 53 and a c is equal to 232. Solving this, we get the value of n. We can find n is equal to minus b plus or minus root of b square minus 4ac by 2a. That is substitute. We get 53 plus or minus b square is 53 square 2809 minus 4ac is 4 into 3 into 232, that is 2784 by 2 into a is 2 into 3 6, which is equal to 53 plus or minus this we will get 2809 minus 2784, that is 25. Square root of 25 is 5 plus or minus 5 by 6, which is equal to 58 by 6 or 48 by 6. 48 by 6 is 8. This is 29 by 2, a fraction. We cannot take n a fraction. N is just a natural number. First term, second term, third term, like that. So we cannot take a fraction. So n is equal to 8. So we get n is equal to 8. Next, substitute this n in a. We already have a and d. Then we will get the last term. So the last term here is 8th term. So we can write a8 is equal to a plus 7d. N minus 1, 8 minus 1, 7. That is a is 25 plus 7 into minus 3. D is minus 3, which is 25 minus 21, which is equal to 4. So the last term is 4. Second question, find the sum to n terms of the series 1 into 2 into 3, 2 into 3 into 4, etc. So here the series is 1 into 2 into 3, 2 into 3 into 4, 3 into 4 into 5, etc. That is a first term. A1 is equal to 1 into 2 into 3. A2 is equal to 2 into 3 into 4, second term. Like that we can write AK is equal to K into K plus 1 into K plus 2. That is product of three consecutive terms starting from the subscript. This is equal to K into K plus 1 into K plus 2. That is K square plus 2K plus K, 3K plus 1 into 2, 2. Which is equal to K cube plus 3K square plus 2K. So the general term is this. If we substitute k equal to 1, we get a1 first term. If we substitute k equal to 2, we get the second term. We have to find sum to n terms. Sn is equal to a1 plus a2 plus etc. plus a. Instead of this, we can write series k from 1 to n ak. That is when k equal to 1, a1. Sigma stand for plus. When k equal to 2, a2. Like that when k equal to n, a. That is a1 plus a2 plus etc. plus a. Instead of ak, we can substitute this formula. Then we get series k from 1 to n, k cube plus 3k square plus 2k, which is equal to, we can separate this. Series k from 1 to n, k cube plus 3 into series k from 1 to n, k square plus 2 into series k from 1 to n, k. Here series k cube. K from 1 to n. This is 1 cube plus 2 cube plus 3 cube plus etc. plus n cube. We know the formula. This is equal to n into n plus 1 by 2 the whole square. And here series k square. Series k square is 1 square plus 2 square plus etc. plus n square. We know the formula n into n plus 1 into 2n plus 1 by 6. And here series k. That is 1 plus 2 plus etc. plus n. Sum to first n natural numbers. That is n into n plus 1 by 2. So substitute this formula, then we will get Sn, which is equal to series k cube is n into n plus 1 the whole square by 2 square, that is 4, plus 3 into series k square is n into n plus 1 into 2n plus 1 by 6, plus 2 into series k is n into n plus 1 by 2, which is equal to here 3, 6, 2 times. We can make the denominator 4. And we can take n into n plus 1 by 4 outside, all common. So we can take n into n plus 1 by 4 into, here remaining is n into n plus 1. Plus here n into n plus 1 by 4 is taken outside. Multiply the numerator and the denominator by 2 to make the denominator 4. So we get the remaining is 2 into 2n plus 1. Plus here multiply the numerator and denominator by 2 and take n into n plus 1 by 4 outside. Then remaining is 4. 2 into 2, that is 4. Which is equal to n into n plus 1 by 4. Just expand this. That is n square plus n plus 2 into 2n is 4n plus 2. 2 into 1 plus 4. Which is equal to n into n plus 1 by 4. This is n square plus n plus 4n is 5n plus 2 plus 4 is 6. This is equal to n into n plus 1 by 4 into n square plus 5n plus 6. We can write n plus 2 into n plus 3. How we can say this is, I have already explained it. We have to make this in terms of n plus a into n plus b. N plus a into n plus b is nothing but n square plus an plus bn, that is a plus bn plus a into b. Here equating we get a plus b equal to 5, coefficient of n, and A into B is equal to 6. That is, product of two numbers is 6 and the sum of two numbers is 5. Then that two numbers are 2 and 3. 2 plus 3 is 5 and 2 into 3 is 6. Like that we can write. So the answer is n into n plus 1 into n plus 2 into n plus 3 divided by 4. Next question, again two part. First one, insert three numbers between 1 and 256 so that the resulting sequence is a GP. Question from the section Geometric Mean. Second one, if P at the term of an AP is Q and Q at the term is P where P not equal to Q, find a rth term. This is from arithmetic progression. These two questions I have already discussed in the previous videos. Okay, anyway we can see. First one, we have to insert three numbers between 1 and 256 to form a GP. So let G1, G2, G3 be the three numbers between 1 and 256. Then 1, G1, G2, G3, 256. We have inserted these three terms to form a GP. So this is a GP with the first term A is equal to 1 and the last term, that is fifth term, A5 is equal to 256. We know the nth term an is equal to ar raised to n minus 1 for a GP. So we can say this is nothing but ar raised to 4. We know a equal to 1. That is r raised to 4 is equal to 256. So r is equal to fourth root of 256. We know 256 is 16 into 16, that is 16 square. And 16 is 4 into 4. Square root of 256 is 16. Again, a square root of 16 is 4. So we can say this is a 4 raised to 4. So r is equal to 4. We can take negative values also. Common ratio can be negative. So we can say r is equal to plus or minus 4. When r is equal to 4, we get G1 is equal to a into r. That is 1 into r, 4. G2 is equal to 4 into 4, that is 16, and G3 is equal to 16 into 4, 64. When r is equal to minus 4, we get G1 is equal to minus 4, G2 is equal to minus 4 into minus 4, that is plus 16, and G3 is equal to 16 into minus 4, that is minus 64. So we can insert 4, 16, 64 in between 1 and 256, or we can insert minus 4, 16 and minus 64 to form a GP. Second question, Pth term is Q and Qth term is P. Find rth term. That is, AP is given which is equal to Q and AQ is equal to P. We have to find AR. We know AR is nothing but A plus R minus 1 into D. Nth term is A plus N minus 1 into D. Here instead of N we have R. Like that, here we can write A plus P minus 1 into D is equal to Q, and here A plus Q minus 1 into D. AQ is A plus Q minus 1 into D, which is equal to P. Take this as first equation and this one second equation. To find AR, we need A and D, that is first term and a common difference that we can get from these two equations. So 1 minus 2. First equation minus second equation. We will get A minus A is 0. Then P minus 1 into D minus Q minus 1 into D. That is P minus 1 minus of Q minus 1. That is minus Q plus 1 into D is equal to Q minus P. Here minus 1 plus 1, 0. That is P minus Q into D is equal to Q minus P. So we get D is equal to Q minus P by P minus Q. Q minus P is nothing but minus of P minus Q by P minus Q, which is equal to minus 1. So we get common difference. D is equal to minus 1. Next we need first term. Substitute in 1. 1 implies A plus P minus 1 into D is equal to Q. Instead of D, minus 1. That is A minus P minus 1 into minus 1 is minus P plus 1. Minus P plus 1 is equal to Q. That is A equal to Q plus P minus 1. Just taking minus p plus 1 to this side. Or we can write this is p plus q minus 1. So we have a and a common difference. Next we can see ar. Just substitute in this formula. Then ar is equal to p plus q minus 1 plus r minus 1 into minus 1. That is minus r plus 1. Here minus 1 plus 1, 0. This is equal to p plus q minus r. So our required term, that is rth term, is p plus q minus r. Next question, we have three parts. We can see one by one. First, geometric mean of 16 and 4 is. We know geometric mean of a and b is root of ab. Root of a into b. So here instead of a we have 16 and b we have 4. So this is equal to 6 root of 16 into 4, which is equal to 16 into 4 is 64. That is root of 64, which is equal to 8. Square root of 64 is 8. Next question, find the sum to n terms of the series 5 plus 55 plus 555 plus etc. We have seen a similar type of question in the section geometric progression. This is not a GP, but we can make a GP out of this. You can see 5 plus 55 plus 555 plus etc. which is equal to, we can write 5 into 1 plus 11 plus 111 plus etc. We can take 5 outside. We can multiply and divide this by 9. Then no change. We can write as 5 by 9 into 1 plus 11 plus etc. That is 9 plus 99 plus, you can write 9 plus 99 plus 999 plus etc. This we are doing to make a GP out of this. Then see, 9 is 10 minus 1, 99 is 100 minus 1. So we can write 5 by 9 into 10 minus 1 plus 100 minus 1 plus 1000 minus 1 plus etc. which is equal to 5 by 9 into, this is 10 plus 100 plus 1000 plus etc. 10 plus 100 plus 1000 plus etc. plus minus 1 minus 1 minus 1 etc. n times. Minus 1 minus 1 minus 1 etc. n times, which is equal to 5 by 9 into, now see, 10 plus 100 plus 1000 plus etc. up to n terms. This is a GP with a is equal to 10. First term 10 and a common ratio r is equal to 10. So this sum we can write. We know sum to n terms of a geometric progression. Sn is equal to a into r raised to n minus 1 by r minus 1 when r is greater than 1. Here r is greater than 1, which is equal to 10 into 10 raised to n minus 1 by 10 minus 1 is 9. So we can substitute 10 into 10, instead of 10 plus 100 plus etc. we can write the sum 10 raised to n minus 1 by 9. Here minus 1 minus 1 minus 1 etc. n times, that is minus n. So this enough. This is the sum. Next question, find the sum to n terms of the AP whose kth term is AK is equal to 5k plus 1. General term is given, we have to find sum to n terms. Here AK is equal to 5k plus 1. We know sum to n terms of an AP is Sn is equal to n by 2 into 2a plus n minus 1 into d. So to find sum to n terms, we need first term and a common difference that we can find from this. First term, when k equal to 1, we get a1 is equal to 5 plus 1, that is 6. So first term is 6. And a common difference, we can find a2, then a2 minus a1 is the common difference. a2 is equal to 5 into 2 plus 1, that is 10 plus 1, 11. Therefore, d is equal to a2 minus a1. Common difference is 11 minus 6, which is equal to 5. So we can write Sn is equal to n by 2 into a. Instead of a, first term 6, 2 into 6, that is 12 plus n minus 1 into, instead of d, 5. which is equal to n by 2 into 12 plus 5n minus 5. 5 into n minus 1 is 5n minus 5, which is equal to n by 2 into 5n 12 minus 5, that is 7 plus 7. So this is the sum to n terms of this AP. Next question, we have three parts, we can see one by one. First one, if the first three terms of an AP is x minus 1, x plus 1, 2x plus 3, then x is, we have to find x. Here first term is x minus 1, second term is x plus 1, third term is 2x plus 3. We can simply find x. Here a1 is equal to x minus 1, a2 is equal to x plus 1, a3 is equal to 2x plus 3. We know a2 minus a1 is equal to common difference, and a3 minus a2 we will also get the common difference. So we can say d is equal to either a2 minus a1 or d is equal to a3 minus a2. So we can say a2 minus a1 is equal to a3 minus a2, same d. So we can substitute a2 is x plus 1 minus a1 is x minus 1 minus of x minus 1, which is equal to d, that is also 2x plus 3, a3 minus a2, x plus 1. This is x plus 1 minus x, minus of minus 1 is plus 1, that is x plus 1 minus x plus 1, which is equal to 2x plus 3 minus x minus 1. This is x minus x 0. 1 plus 1, 2. 2 is equal to 2x minus x, that is x, plus 3 minus 1, that is 2. That is x plus 2 equal to 2, or we can write x is equal to 2 minus 2, which is equal to 0. Next question, find the sum to n terms of the sequence 1 into 2, 2 into 3, 3 into 4 from section sum to n terms of special series. Here first term is a1 is equal to 1 into 2, a2 is equal to 2 into 3, a3 is equal to 3 into 4. Like that we can say the general term ak is equal to k into k plus 1, which is equal to k square plus k. So sum to n terms Sn is equal to a1 plus etc plus an, which is equal to series ak k from 1 to n. Instead of ak, substitute k square plus k. This is equal to series k from 1 to n, k square plus k. We can separate this series k from 1 to n, k square plus series k from 1 to n, k. Series k from 1 to n, k square is 1 square plus 2 square plus etc plus n square. That is, we know the formula sum to n terms of squares of first n natural numbers, n into n plus 1 into 2n plus 1 by 6. Plus series k is 1 plus 2 plus etc plus n, sum to n terms of first n natural numbers, that is n into n plus 1 by 2. This formula we have. We can take n into n plus 1 by 2 outside, which is equal to n into n plus 1 by 2 into, here remaining is n into n plus 1 by 2 taken outside, remaining is 2n plus 1 by 3. 2n plus 1 by 3 plus 1. Making the denominator common, we get n into n plus 1 by 2 into 2n plus 1 plus, here 3 by 3. 2n plus 1 plus 3 is 2n plus 4 by 3, which is equal to, here 2n plus 4 is 2 into n plus 2. That is n into n plus 1 into by 2 into 2 into n plus 2 by 3. Here 2 get cancelled. That is n into n plus 1 into n plus 2 by 3. So the answer is n into n plus 1 into n plus 2 divided by 3. This we have already discussed. Next question, the nth term of the GP 5 minus 5 by 2, 5 by 4, 5 by 8 is 5 by 1024. Find n. Question from the section geometric progression. Here given the GP 5 minus 5 by 2, 5 by 4, etc. So A is equal to first term, A is equal to 5, and common ratio R is equal to second term by first term, that is minus 5 by 2 divided by 5, that is into 5. This is equal to minus 5 by 10, which is equal to minus 1 by 2. So common ratio is minus 1 by 2. Here given nth term is 5 by 1024. That is an is equal to given 5 by 1024. We have to find n. We know an is ar raised to n minus 1, which is equal to 5 by 1024. We know a is equal to 5 and r is equal to minus 1 by 2. That is 5 into minus 1 by 2 the whole raised to n minus 1 is equal to 5 by 1024. Here we can cancel 5 and 5. That is minus 1 by 2 the whole raised to n minus 1 is equal to 1 by 1024. We know 1024 is 2 raised to 10. Or we can say minus 2 raised to 10 is also 1024. So we can write minus 1 by 2 the whole raised to 10. So equating we get n minus 1 is equal to 10. N minus 1 is equal to 10 or n is equal to 11. So the answer is n is equal to 11. Next question, we have three parts. First one, the nth term of the GP 525 125 is dash. So here a first term is a equal to 5 and a common ratio r is equal to 25 by 5, that is 5. So we have to find nth term. N is equal to a r raised to n minus 1, that is 5 into 5 raised to n minus 1. This is equal to, we know a raised to m into a raised to n is equal to a raised to m plus n. So we can write 5 raised to 1 plus n minus 1, that is n minus 1 plus 1, that is n, 5 raised to n. Next question, find the sum of all natural numbers between 200 and 1000 which are multiples of 10. This is a question from arithmetic progression. We can see the numbers between 200 and 1000 that are multiples of 10. 200 and 1000 not included. So the first term is 210. Next 220, etc. Like that, the last term we can say 1000 minus 10, that is 990. So we can write a is equal to 210 and d common difference is equal to 10. We are adding 10 and last term an is equal to 990. From this we can find n. That is an is equal to a plus n minus 1 into d. Instead of a we have 210 plus n minus 1 into 10, which is equal to 210 plus 10n minus 10, that is 200 plus 10n. N is 990 given, that is 200 plus 10n is equal to 990. Therefore we can write 10n is equal to 990 minus 200, that is 790. So n is equal to 790 by 10, which is equal to 79. So we have n. Now we have to find sum to n terms. Sn is equal to n by 2 into, we have the formula 2a plus n minus 1 into d. For an arithmetic progression, Sn is this one. So substitute all n, a and d. N is 79. 79 by 2 into a, that is a is 210. 2 into 210 is 420 plus n minus 1 into, that is 79 minus 1, 78 into d. D is 10. 78 into 10 is 780, which is equal to 79 by 2 into 420 plus 780, 1200, which is equal to 79 into 1200 by 2, that is 600, which is equal to 79 into 600, 47400. So this is the answer. Instead of this formula, we can use Sn is equal to n by 2 into first term plus last term, a1 plus an. That is n by 2, 79 by 2 into first term is 210 plus last term is 990. This also we get 47400. Anyway, you can write. Next question, calculate the sum of n terms of the series whose nth term is n is equal to n into n plus 3. Question from the section sum to n terms of special series. here nth term an is given. So we can write the general term ak is equal to k into k plus 3. When k equal to 1, we get first term, k equal to 2, we get second term, etc. So we have to find sum to n terms. Sn is equal to a1 plus etc. plus an, which is equal to series k from 1 to n ak. Ak is k into k plus 3, that is k square plus 3k, which is equal to series k from 1 to n instead of ak, k square plus 3k, which is equal to series k square k from 1 to n plus 3 into series k from 1 to n. We know series k square is equal to n into n plus 1 into 2n plus 1 by 6 plus 3 into series k is n into n plus 1 by 2, which is equal to, we can make the denominator common, 2 into 3 here into 3, then the denominator is 6. So we can write n into n plus 1 by 6 outside, n into n plus 1 by 6, here remaining is 2n plus 1 plus here remaining is n into n plus 1 by 6 taken outside, remaining is 9, which is equal to n into n plus 1 by 6 into 2n plus 10, that is 2 into n plus 5. 2n plus 10 is 2 into n plus 5. This is 3. 2 by 6, 1 by 3, which is equal to n into n plus 1 into n plus 5 by 3. So we have discussed the questions from all the sections. We can see more questions in the next video. If you find this video useful, please like, share, comment and subscribe. Thank you for watching. Thank you.